Okay, Algebra 2, this is the second half of the notes for section 09, which we started yesterday. We talked about standard deviation yesterday, and then we're just going to do this little bit of notes right here, which doesn't seem like a whole lot, but there's quite a bit of stuff to do, so it is going to take just a little bit of time. But and then your homework assignment will be the back side of that worksheet that you started yesterday. So just these two problems, that there's like an A and a B and a C and a D even on number 6. So this will be your homework for today, but we'll finish these last couple problems for notes. Okay, so the first thing that they talk about is something called a 5-number summary, which is what you use to create a box and whisker plot. So I'm going to write box and whisker plot. Okay, and a box and whisker plot, if you don't know, is something that looks like this, right? Okay, and for your box and whisker plot, you have 5 numbers, which is the 5-number summary. You have the number here, which is your minimum number. So minimum, I'm going to say minimum. Then you have a number here, which is your maximum, which is your biggest number. And then this one here in the middle, the middle of that box, is the median, the overall median, okay? This little edge of this box is something called a quartile 1, or the lower quartile they put here. And the lower quartile is just the median of the first half of the data. So it's you find the median, which is halfway between the maximum and the minimum, and then you find the median again of this middle chunk here, okay? And then this one is the quartile 3, or kind of the third quarter of data, and that is just the median again, but of that second half of data, okay? So you're finding the median 3 times when you're doing this process, okay? And that's what the 5-number summary is. So first thing that we need to do is put data in order when we get them. So the number of hours Liliana worked each week for the last 12 weeks were as follows, okay? And so I'm going to put these in order, and I see the number 10, I think, is my lowest number. And then I see a 12, and then I see a 13, and then I see 14. 15. Usually I have you guys help me with this, but since I'm not there in class, I can't get help, so I'm on my own here. 16, 18, and another 18. And then we have a 19. It's going right below itself. 20, 20, and 21. So 2 20s and a 21. And because I put them right below, I know that I didn't miss anything, okay? Now we know that we have 12 numbers, okay? So when we split them in half and find that median, we will not have an exact middle number, okay? So I'll have 6 numbers on the one side, the first through the 6th number, right? And then I'll have 6 numbers over here, which are the 7th through the 12th number in that, in order. So my median will be my 6th and 7th number, okay? But before we do the median, let's find the minimum. So I'm going to do, let's just do this. The minimum is 10. The maximum is 21. I just get that from the end to the beginning, okay? Min is 10, max is 21. And then we know the median we just said was this between the 6th and 7th number. So I have 1, 2, 3, 4, 5, 6, 7. So I have 2 middle numbers, which are 16 and 18. And so what I do is I find the average of those two, and that is 17. So the median is going to be my number 17. Okay, now, because 17 was not an actual number in my data set, I'm going to use this number as this, where I've put my brackets at, that is where I am going to do my separation of my first half of data, and this is where I'm going to do my separation of my second half of data, okay? I'll show you a scenario here in just a second when that is kind of weird. Okay, so in my first half of data, I have 6 numbers, and I'm trying to find the lower quartile, which is basically just the median of those 6 numbers, okay? So you can kind of see that if there's 6 numbers, these are my 2 middle numbers. And so I average those together, so this lower quartile, or Q1, is going to be 13.5. Okay, and then I do the same thing for these 6 numbers, and the middle 2 numbers are going to be 19 and 20, so my upper quartile is going to be 19.5 or 19.5. okay? And those are gonna be my 5-number summary, okay? Now, I'm gonna do one more little example over here, and if you wanna write this down, you can, because this is kind of a weird thing that happens. So let's say my data set has only 7 numbers in it, okay? So I'm gonna do the numbers 1, 2, 2, 4, 5, 8. That's 6 numbers, and 11, let's say. Those are my 7 numbers, okay? So when I'm finding my minimum, that's gonna be 1, my maximum is gonna be 11, and then the middle number is gonna be this number 4, okay? And in this data set, since I had 7 numbers, I will have an exact middle number, right? Like 7 numbers is an odd number, versus over here when I had 12, I did not have an exact middle number. So let me show you the difference between the two. Because I did in fact have an exact middle number, what I'm going to do is I'm going to take and I'm going to cross that number off. And when I go to find the Q1, I only use these numbers and I don't use that median, okay? And when I go to find Q3, I only use these numbers, okay? So my Q1 is gonna be 2 and my Q3 is gonna be 8, okay? So if you do have an exact middle number, you cross it off and you don't use it. Versus over here, my middle number was actually 17 because it was the average of these two. So I didn't cross anything off and I used 16 in my first half of my data and I used 18 in my second half of my data. Okay, so that's kind of a weird thing that happens depending on whether you have a median or you have 2 numbers that are your median, okay, and that's kind of how that works. That's kind of the general accepted rule, okay? So we have our 5-number summary, and then it says interpret this 5-number summary. So we're gonna do that by constructing a box and whisker plot, and I make you do that on your homework assignment. So this can help us kind of see like how spread apart the data and stuff is. So what I'm going to do first is I'm going to create a number line at the bottom, and I'm going to do this. I'm going to make a straight number line at the bottom, and we're going to go, I'm going to go 10 here. I'm going to go, let's see, I'll go, let's go 10, 12, 14, we'll just go by 2s, 16, 18, 20, and 22, okay? I make this number line at the bottom so that this doesn't happen. This is my favorite thing when I have kids that make box and whisker plots, okay? I'll have box and whisker plots that literally look like this, okay? All right, a lot of times your box and whisker plots are like this symmetric, but I'll have like 2 here, and then I'll have like 90 and 95 and 99 and 100 for my numbers for each one of those, okay? Now, that's obviously not spread apart and grouped the way that it's supposed to be. Like, there's a lot of numbers between 2 and 90, so this should be, like, this box of whisker plot should look like this, right? Like, that's how it should look, because this is really spread apart, okay? So that's why I make a number line ahead of time, so that it prevents me from like trying to make it look distributed a different way than it should be, okay? So now I just fill my numbers in. So 10 is my first number. That's my minimum. My maximum is 21, so I'm gonna put that here. Then I have 17 is my middle number here. I'm going to put a line there. And then I have 13 and a half, which is about there. And I have 19 and a half, which is about there. Okay, so I have kind of this thing going on. There's my box and there's my whiskers, okay? And so I have that thing going on, okay? And this box and whisker plot can tell you a lot of things based upon like when I look at these chunks, this chunk versus this chunk versus this chunk versus this chunk, okay? Those 4 chunks have exactly the same number of numbers in them, okay? And what I mean by that is we had 12 numbers to start with. So there are 3 numbers that live in this range. There are 3 numbers that live in this range. There are 3 numbers that live in this range, and there are 3 numbers that live in this range. What people mistake in a lot of times is they say, okay, like this is the biggest region, so this obviously has more numbers stuffed into that little chunk. That's not true. And this one is obviously the smallest, so that has the smallest or like the fewest numbers in that chunk. They all have 3 numbers in there. It's just that these numbers in this chunk are more spread apart than these numbers. These numbers are closer together. And you can kind of see that with the data. Like we have 10, 12, 13, 14, 15, and then we've got a bunch like 18, 19, 20, 21. Those are really, really close together versus these are kind of a little bit more spread apart. So that's kind of like what we can gather from this box and whisker plot, is that like the spread of the data can show us, you know, like which intervals are closest together, okay? And another way I think of this is like let's say a basketball game, maybe, okay? In a basketball game, there's 4 quarters, right? So there are 8 minutes in each quarter, right? There's not one quarter that's different than that. There's 8 minutes in each quarter. We're assuming that you're not going into overtime, right? Okay, so 8 minutes each quarter. I think it's 8. Yeah, I'm pretty sure. 8 minutes each quarter, and then, but some quarters can feel like they're longer than others. And usually it's this 4th quarter that ends up being like this long, because the 4th quarter drags on forever because they're constantly stopping the clock and everything. So just because it looks longer and it feels like it's longer, and it is longer, doesn't mean that there's more time on the clock than there is in any one of the other quarters, if that makes any sense. So that's kind of one way to think about your different quartiles, is what these are. Is that there's the same number of numbers in each one, but it just talks about how spread apart they are, or like how much time it's taking up for each one, okay? Hopefully that made a little bit of sense, but interpret this 5-number summary. I'm gonna say the 4th quartile has data that is the closest together. Okay, so this chunk right here, since it is very small, that means that data is just really close together, okay? So that's kind of one interpretation of this box and whisker plot, okay? All right, example 4, this is the last one. The number of minutes that each of the 22 students in a class spent working on the same algebra assignment is shown below. That whole big long thing, okay? It says identify any outliers in the data, okay? And an outlier is a number that's either really, really, really small, like away from the rest of the data, or really, really, really large away from the rest of the data, okay? That outlier can affect the data in a lot of different ways, and we're going to talk about those effects down here in the second part B, okay? So what I'm going to do first is, before I do an outlier, I'm going to list these out in order. And I went ahead and cheated a little bit, and I put these on my spreadsheet on my computer, and I sorted it, and I had them, I had it sort the numbers for me. So if I list them in order, the numbers are 10, 12, 13, 15, 15. There are 4 15s. 1, 2, 3, 4. 4 15s. Okay, then there is a 16, 2 18s. There is a 20, 2 22s. There is 1, 2, 3, 4 25s. 25, 25, 25, and 25. Then there is a 27. There's a 28. There's a 30. There's a 35. Oh, I'm running out of room. And a 65. Okay, there's my data. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Perfect. 22 numbers. All right, there they all are. Okay, and identify any outliers. So when you're looking for outliers, you're looking for either this number as being an outlier or this number as being an outlier. Now 10, the next closest number is 12. Those are pretty close together. Okay, but 65, the next closest number is 35. So I'm going to say that 65 is an outlier because it's like way far away from the rest of the data. Okay, you see outliers probably, hopefully you don't see this outlier all the time, but if you're typically good at getting good grades and get like 90s to 100s, and then all of a sudden you like miss an assignment or something and then you get a 0 put in the grade book, that's a huge outlier, and it brings your average, I'm sure you've probably seen that if you've ever had a 0 in the grade book, it brings your average way down because that outlier is just way far away from all of the other grades that you're getting, and it really pulls your average down. Okay, so identify the outlier in this data set, I'm going to definitely say that it's 65 because that's way, way, way far away from the data, okay? All right. This one says find the mean, median, mode, range, and standard deviation of the data set with and without the outlier. So I'm going to say with the outlier. I'm going to make kind of a table with the outlier, which is 65, and then I'm going to say without the outlier. Okay, with and without the outlier. And we're going to do, I'm not going to do standard deviation. I don't ask you to do that on your homework assignment because like that's the really tedious, ugly one that has the table. So we're just going to do mean, and we're going to do median, and we're going to do mode, and we're going to do range, and then we are going to compare those things, okay, and like talk about like, okay, did it change this a lot or did it only change this a little, okay? So there's those numbers, all right? Let's start with range. That one's nice, okay? Range is the easy one, and range with the outlier is going from 10 to 65, okay, and that is a range of 55 numbers. Versus if I knock that 65 out, now I'm only going 10 to 35, which is 25. Holy cow, that changed a lot. So I'm going to say big change here. It is going to change that number a lot. And if you think about it, an outlier, like especially a 0 in your grade book, that's going to be like, you know, change your range a lot. Your range of grades is going to go from 0 to probably 100% versus going from like 90 to 100%, okay? So big change when you remove the outlier, okay? Now let's go to mode, okay? The mode is the number that occurs the most, and I had four number 15s, and I had 4 25s, okay? So I have two modes. I have 15 and 25 with the outlier. Now, as soon as I remove that 65, 15 and 25 are still appearing the same number of times. Now, will that always happen? Well, it should always happen. It should always be the same thing, that the mode will stay the same, because the 65 that I'm removing, or this number, if that's truly an outlier, it shouldn't be the number that appears more than once, right? So 65 should not be the mode ever, because that's an outlier, right? If it appeared more than once, it wouldn't be an outlier. So by removing that 65, the mode just didn't change. So I'm going to say right here that there's absolutely no change with a mode when I have the outlier versus not have the outlier. And that will always be the case, not just for this data set, okay? The median, I'm going to go, okay, the median, we had 22 numbers, right? 22 students with the outlier, okay? So if I do 22, I have 11 over here and 11 over here, and I have the first term through the 11th term here, and I have the 12th term through the 22nd term here. I hope that makes sense, right? 11 terms on the one side, 11 terms on the other side. So it is going to be between the 11th and 12th number, if I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These two numbers are my median, okay? So 20 and 22, halfway between those, or if I take the average of those, is going to be 21 is my median, okay? And then if I knock that 65 out of there, okay, now I only have 21 numbers. And 21 numbers, if I separate that in half, I'll have 10 numbers over on this side, I'll have 10 numbers over on this side, and 1 number in the middle. Okay, that adds up to be 21 numbers total. So this will be my first 10 numbers, and then my 11th number is going to be the middle one. Okay, I can count from either side. I can either count 10 back this direction, and this is the 11th one, or 10 this direction, and this is the 11th one. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 11 is this number, right? Number 20. So we moved from being halfway point, which is 21, to just one step right below it, which is 20. Okay, and that median will not experience too terribly much of a change, right? It'll just go from like a half a step like down, or a half a step up, depending on where your outlier is at. It will move just a half a step, okay? So I'm going to say not much change, and I'm going to say just moving half of a number over, if that makes any sense. I'm just going over half of a number. So like I'm going from the 11th term to halfway between the 11th and the 12th term, or vice versa, right? I'm just moving half of a number over, okay? All right, and then the mean is the average again, okay? And I went ahead and I just had this my computer do it for me. So the mean again is adding up all of the numbers and dividing by the number of numbers that you have. So I've done that already, and with the outlier, it was 22.5, okay? Now let's take a guesstimation. That's with the 65 in there, okay? Let's take a little guesstimation as to what's gonna happen if I yank that 65 out, okay? So 22.5 is my average. And if I take that 65 number out, I'm taking out a really big number. So the average is probably going to go down, right? Okay? Because I'm yanking out that top number, the average is going to go down. So I did that, and I got the average to be 20.5. So it goes from about 22.5 to about 20.5. And so this has a change. The average does change, and it just kind of depends on what your numbers are to how big that change is. So like the example that I was talking about before, if you have like a 90 in the grade book and a 92 and a 100 and a 98, and then all of a sudden I lump a 0 in there, that's a huge change from these numbers, and your average is probably going to go from like a 95 all the way down to maybe like a 42 or something like that. I'm just throwing that out there, right? Because that's a huge change. So my average will decrease a ton, okay? But, you know, like my smallest number was 90 before, and then it goes to my smallest number now being 0. That's a bigger change than going from 35 to 65. So our average only changed about 2 points, but it has the potential to change a ton depending on what my numbers are, okay? So I'm just going to say it has a change. In this case, it was only 2 points, but it could be way, way, way higher than that, okay? So which one changed the least? The mode has the least change because it doesn't change at all, okay? The next one would probably be the median. Okay, so I'm going to say this one has the second least amount of change because it's only moving just a little bit, okay? Then the mean probably is the next one, and then the range has the biggest change. That's going to be like where a bunch of it occurs, okay, your biggest change. So even if your mean is you know, going from 95 to 42, your range is still going from 10 points, from 90 to 100, down to like 100 points, okay, or up to 100 points. So your range will always have the largest amount of change, okay? So hopefully that made sense. That was a lot of information and a lot of data, but try some of these homework problems on the back side here with some of the data. If you want to work together and help sort these out, at least put them in order, that would be a really good idea. And that is all I have. Okay.